My name's Faisal.
And I'm Tyler.
And we did, for our final project, a password-protected alarm for high temperatures. So the requirements for alarm system was that we wanted it to be secure, so it was password-protected if you wanted to adjust the parameters or if you wanted to access it. And the basic idea is an alarm sounds whenever the temperature rises above a certain threshold. And we wanted to differentiate, two levels of thresholds and differentiate that alarm sound by the frequency of the alarm. And so those temperatures thresholds are configurable, and we wanted the device to be as accurate as a thermometer to 1 degree.
Okay, so for the hardware, the user can input their password and whatever temperature they want to set the threshold on the PuTTY terminal from the keyboard, and that works through USART, connects to the Arduino board, and then once you input the correct password, the temperature as well as the threshold temperature shows up on the LCD screen, and the TMP36 sensor connects to the analog digital converter, and that's how we get the temperature for the LCD. And then we output a sine wave, kind of like our project, to the waveform generator through the DAC, and that goes to the speaker if there is going to be an alarm sounding based on the threshold temperatures. And for the software, we have a state machine. It starts out in password protected mode, and it loops back around to that same mode if you type the incorrect password. Otherwise, if you type the correct password, it goes to a user control state where the user can enter their preferred threshold temperature. And then it goes to the measurement state where it loops and shows you the current temperature and will sound the alarm if the threshold temperature is exceeded, or the higher frequency alarm if the threshold temperature is exceeded by a larger amount.
So one of the main things that we had to do is, because since we were using so many inputs on the Arduino board, we had to configure the LCD enable mode. And for the security password inputs, we used UART, and we connected through the PuTTY terminal. And to actually output different frequencies onto the speaker, we had to output a lookup table for the sine wave, and then adjust that frequency using timer inputs. And then there was the whole ordeal of calibrating the temperature sensor to match an actual thermometer.
So integrating the LCD with the SPI proved difficult just because of the way we set up one of our buses. We had to move our pins around, but we eventually figured it out. It wasn't incredibly bad, but it took us a little bit of time just because sometimes they would override each other and then we'd get some very weird outputs. Speaker limitations, well, one, it was very quiet, so we borrowed some speakers from another group, thank you. And at first it was just outputting a sound constantly, but we solved that by adding a diode so that when the voltage is too low, it can't pass through the diode and there's no sound. And then one of the main problems actually.
And we did most of our testing in line with the thermometer and just in variable temperatures and sort of dropping and rising to see if the alarm would go off or not. Yeah. So definitely there. And enter a password that's incorrect. It says incorrect password. That's the right password. And now I can set some sort of threshold temperature. So if I set it to like 27, it'll show the temperature in the room and then the limiting temperature.
So currently it's about 24 or 25 degrees Celsius in the room, and if I grab onto the temperature sensor, it'll warm up. And there it goes.
And if it gets 5 degrees above that threshold,
So let me see if I can get it to go to 32 degrees C. Doesn't seem to want to, my fingers don't seem to be all that warm, so it's not going that quickly. It's at 30 out of 32.
We can reset it.
Rub your hands together.
Run it again on a lower threshold.
Yeah, we can just reset it.
Okay.
Reset it.
To do that, all you have to do is reset it and it goes back into password protected mode.
This time I'll set it at 25, which is about here.
Which means it's already going off, and if we get it to 30, slowly.
There you go.
There you go. There's the higher tone. And then it cools back down.
Yeah.
Oops.